Hello and good afternoon, CTS265 Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on Discovery Activity number 17, where we're now going to be manipulating redistribution using route maps. So this is the third in a series of 3 discovery activities that we've looked at for Chapter 4 so far. The first was simply how to perform basic redistribution, where again we had redistribute statements that would redistribute all OSPF routes into EIGRP and all EIGRP routes into OSPF. We looked at the subnets and the include connected statements that were required to make that happen on both sides for both protocols, V4 and V6. And then we transitioned to using ACLs and distribute lists and distribute lists and prefix lists in order to sort of manipulate and scope down or filter that which we were redistributing. And again, remember that distribute list statement is nothing more than a call to action for the routing protocol to perform its filtering. So now we're going to take the final step in our discovery here on manipulating redistribution by using route maps. So what we have now is multi-point two-way distribution. And so this was what I was talking about early on in the first activity, I believe, where now we've got a possibility here if we're redistributing EIGRP into OSPF and redistributing OSPF into EIGRP, and we're doing that on both of these border routers. Now we've got the possibility, this is a very dangerous thing to do, we've got the possibility of routing loops, right? Because as information is being redistributed in, that same information is really having its identity stripped away. Because what we're saying is, depending on which way we're going here, we're either taking OSPF originated information and sending it into EIGRP, in effect stripping the OSPF characteristics from those routes, or we're doing just the opposite. We're taking EIGRP routing information, we're sending that into OSPF, and then we're stripping those EIGRP routes of their EIGRP characteristics, and then they end up with OSPF characteristics. And so we're going to see how we would handle that. And again, these last 3 activities are absolutely priceless activities, very, very good activities in terms of redistribution. So let's go ahead and let's make this happen. So the first thing we need to do is configure redistribution between OSPF and EIGRP on both router 1 and router 4. Again, two-point or two-way multi-point redistribution. So let's get into privilege exec and into global config. We'll say do show run section OSPF. So the OSPF section exists, do show run section EIGRP. But unlike Discovery 16, we don't have redistribution configured for us. So we're going to have to make that happen. So let's say router OSPF 10. Router OSPF 10. Now remember, when we're under the OSPF global configuration section, we are redistributing from EIGRP, and the EIGRP process ID, or autonomous system number I should say, is 100. But remember, we're sending this into OSPF. So what is the key option that we need here in order to ensure that all classless networks are included? Exactly. It's that subnets option, which kills me every time. I seem to forget that option more than any other option when I'm doing redistribution. So we've got the redistribute EIGRP 100 subnets command. Now let's get into router EIGRP 100, where we're going to say we're redistributing from OSPF process ID 10, and we have to put a metric, right? Because remember, we're taking this routing information out of, and let me make sure I'm backwards here. We're taking this routing information out of OSPF and sending it into EIGRP. So we're going to stick with the 1500, and we'll do 100, and what is it, 1, and or is it 115? What are some of the options here? 255, 1, and 1500. So again, just throwing some numbers down here. It's not really going to have that much of an effect, if any, on this information. So we've done the mutual redistribution on router 1. We've redistributed from OSPF into EIGRP and from EIGRP into OSPF. But now we need to do the same thing down here on router 4. So let's jump onto router 4. Let's get into privilege exec and global config, and I'm going to assume here, let's see, do show run section OSPF that it's still 10, and it is, and do show run section EIGRP, and it is 100. So router OSPF 10. Remember, we're going to redistribute from EIGRP autonomous system 100. So we're sending everything in from AS 100, and we need the subnets. So when we redistribute to EIGRP 100, when we redistribute the OSPF information from OSPF process ID 10, we're going to set our metrics to 1500 and what did I say? 100, 255, whoops, 1 and 1500, right? So there we go. So the mutual redistribution on router 1 and router 4 has been accomplished. Let's take a look now at router 3 and router 2 to see how they're viewing things in the environment. So I'll say show IP route EIGRP, and then show IP route OSPF. So there, I'm sorry, shouldn't have done OSPF. This is on the OSPF side. So there's the routing information we're seeing, and we know that these OE2s, these OSPF external type 2s, which are right there, that these are as a result of redistribution. And when we look at this, you can see that even though we're redistributing from 4 and from 1, that it's saying via, right? I'm seeing that next hop is 172.16.0.2 for everything there, even though we've done mutual redistribution. So let's go ahead, and we want to make sure that we don't cause any loops. And so I think we're going to be manipulating some additional information here. Give me a second. Let's go over to router 2 in the EIGRP autonomous system here, and let's say show IP route EIGRP. And this is going to show the information that we're learning from the OSPF side, right? The 10.10, 10.11, 12, 13, 4, 5, 6, 7. Right? So all of that information is being redistributed in, and we're learning that as externals. So now what we want to do is we're going to configure an ACL, because we're going to manipulate the way, or manipulate the routes that are actually being allowed to be redistributed. So it looks like we're going to allow the 10.20, the 10.1, the 10.2, and we've got some different subnet masks here, 255, 255, 252.0, and then 248.0. So let's get on to router 1 here. And again, we're going after, which networks are we going after here on 1 and 4? So it's these 10.1 networks here, and it looks like they've summarized. It looks like they're going to go after the summary. Is that right? Let me work this out real quick. So there's an ACL, but the masks appear to be summarized. So if I was to summarize this, it would be 0, 1, 2, 3. So it's going to be 10.1.0.0 slash, that should be a 22, which would be 23 is 254, 248. Is that right? Yeah, that does appear right. So that would be a 248. 248. Okay, so it looks like they're doing the ACLs, and they're going to do it on basically sort of using an ACL to do like a mini summary in order to permit or deny. And they're doing the same thing over here. 10.2, 0, 1, 2, 3. Okay, so let's go ahead and hop in here to router 1 is where we want to be, and let's create the ACL. So we're going to say access list, and you can give it pretty much any number that you want. So we'll just say ACL 1, and we're going to permit the 10.2.0.0, whoops, not 0, 0.0.3.255. So in other words, the 10.2.0.0 but the subnet mask is 255.255.252.0, so it's a /22. And then we're also going to create another separate access list. We'll say access list 2 permit for the 10.0 or 10.1. Sorry, 10.1.0.0. 0.0.7.255. So this is going to be a 255.255.248.0 or /21. And then these same two ACLs are going to be configured on router 4. Again, remember, we're doing mutual redistribution here, multi-point redistribution. So access list 1 permit 10.2.0.0.0.3.255. And then access list 2 permit 10.1.0.0.0.7.255. So again, the exact same ACL statements, because we're going to go ahead and only allow those addresses through, it looks like. So now we get into the route map, right? Because you could do a distribute list, and we saw that in the previous discovery activity. But what we're about to do now is we're going to change some things. We're going to match on certain things, but then we're going to manipulate things. Specifically, we're going to be manipulating the metrics. So on router 4, if I were to say, say route map, and we're just going to call this into underscore OSPF, permit 10. So now we're into the route map configuration. Well, now we need to match IP address. And remember, we're not using a prefix list. If I was using a prefix list, I would say prefix list. But we're using just a common ACL. So match IP address 1. And that's going to match in the route map. If this matches, then what are we going to do? Right? So again, I'm just simply matching IP address 10. And then what we're going to say is route map into underscore EIGRP permit 10. So we're creating another route map called into EIGRP, where we're going to say match IP address 2, which is our ACL. And what are we going to do if we match that? We're going to set the metric, and I'm going to set it to, we'll set it to, what is that, 100,000? 1, 2, 3. We'll set it to 10,000, 10, 200, 5, 1,500. And this is the example that they show you, right? And so that is it. We've created 2 route maps, right? So if I were to say do show route map, they're the 2 route maps that we have. And you can see that the set clauses are listed out. So for the EIGRP routes, we're going to manipulate the metric. For the OSPF routes, we're not actually changing anything. So now let's go do the same thing over on router 1. So let's do the same name. So we're going to say route map into underscore OSPF. Whoops. And that would have been permit 10, again, because if you don't type it, that's the default. So match IP address 1, which is my ACL, and then that's it, right? We're just saying that we're matching that, which means when I apply this route map, it's going to check that first permit clause, and if there is a match of the match IP address 1, which would be the 10.2.0, the 10.2.0.0, then that's going to be allowed, permitted. And again, remember, there's that implicit deny at the end of the route map. So there's an implicit deny at the end of the prefix list, but there's also an implicit deny at the end of the route map itself. Okay, so match IP address 1, and then we're going to do our other route map, which is going to be route map into underscore EIGRP permit. And again, you don't have to type permit 10, right? So I could leave that off. So I'm going to say match IP address 2, which is my second ACL, and if there's a match there, I'm going to manipulate the metrics on those to 10,000, 10, 200, whoops, 200, 5, 1,500, right? So those would end up having different metrics. Now, what we need to do is we need to attach the route map statement to the end of the redistribute command. So if you're following along, we're on step 5. So on router 1, I would say router EIGRP 100, and we're going to say redistribute OSPF 10, route map, and now this is where I put my route map in, right? we're going to go ahead and say into underscore EIGRP. Because again, we're redistributing OSPF into EIGRP, and all we're really doing with this route map is we're setting the metrics. So you'll notice I don't say metrics. So if I were to pull this back real quick and say do show run section EIGRP, right? You see the redistribute OSPF command, correct? And we've got that metric statement there. Well, all I'm doing when I say redistribute OSPF 10, and then I put the route map command in there, and I say into underscore EIGRP, I'm simply replacing the fact that I've got that metric statement in there, the 1500, 100, 255, 1, 1500, with what I have set in my route map. And then the same goes for router OSPF 10. When I say redistribute EIGRP 100, subnets route map, into OSPF, I've done what I did in the, I've basically redistributed it, but I'm matching on what's going to match that access list in the route map. And that is what's going to be allowed to be redistributed from router 1 or from EIGRP on router 1 into OSPF, right? So now we're going to do the same thing again on router 4. We have to make sure we do the same thing because we've got these two ABRs and we have multi-point redistribution taking place. So router EIGRP 100, so I'm redistributing OSPF process ID 10 routes into EIGRP. Now normally I would have to say metric and give the metric values, but here we're going to use our route map to do that. Into underscore EIGRP. And then we do the same thing for OSPF. We say router OSPF 10, redistribute EIGRP process ID 100 subnets into, I gotta put the route map into underscore OSPF. Now, this is a great example of one way with IGPs to use the route map. But now let's go take a look on router 2 and router 3, and let's see what the results of this were. So there's the routing table before the change. Here's the routing table after the change. And we have some differences, right? So I've got my 10.4, 5, 6, and 7. But then what don't you see? Exactly. Where are the 172 16s? So when we redistributed from OSP, I'm sorry, from, which way am I at? Let me get my bearings here. Hold on a second. 3. So from EIGRP into OSPF. So when we redistributed from EIGRP into OSPF, what did we end up doing? We had that route map that said was into underscore OSPF. So show route map into underscore OSPF. Or I'm sorry, it wasn't the route map. It was the yeah, didn't we name the route map into OSPF? Oh, I'm on router 3. I apologize. Let's get on to router 1 here. So what did we say? So do show run route map into underscore OSPF. Do show route map, sorry about that, into underscore OSPF. We will get this. There we go. So we're matching access list, and we're matching access list 1. Do show access list 1, which is permitting all of the subnets in the 10200/22 network range, right? And you can see we had 4 matches on that ACL. But again, this is all that's allowed. So if you're not in the 10.2.0.0/22, then you're not allowed. And so when we look here, you can see that we've got, these are intra-area. Remember, those are intra-area OSPF routes. So those are not the ones being redistributed. Here is what's being redistributed. And all of those fall in the 10.2.0.0/22 range. And so that's why this is all we're seeing. So we basically are using the route map to go ahead and do some filtering for us. All right, so that's what router 3 sees, and it's in the OSPF domain. Now let's go over to router 2 in the EIGRP domain, and let's say show IP route EIGRP. All right, so now we end up seeing these EIGRP routes here, and take a look at the metrics which we changed. Remember, we increased the bandwidth. And so instead of, what is that, 1.7, 123, so 1.73 million, when I increased the bandwidth by a factor of 10, we ended up with 258,000. So that you can see what's happening here is we're using the route map to manipulate the metrics of the different routing protocols. All right, but one of the things that's happening, and hold on one second here, I want to make sure I'm covering everything. Looking at step 7 right now to make sure. Okay, so step 7 is talking about on router 1. And here's where we get into the scenario of changing some of the metric weights. You'll notice that is that's an Ethernet 10 megabit a second. There's 10 megabit a second, 10 megabits per second. And then here's the serial, which is 1.544 megabits per second, right? So if we get on to router 1, let's see what router 1 shows as its preferred path to the 10.1.4, which is this loop back here on router 4. Does it prefer to go here and then over here, or is router 1 going to go from, and that's a terrible choice of color right there, or is it going to go from here to here to get to that network? Keeping in mind that these two hops are over 10 megabit per second links, and this direction is over a 10 megabit per second link, but then a 1.544 per megabits per second link. So we obviously want it to go this way and not that way. So let's see how can we make that happen here. So let's take a look on router 1. We know which way router 4 is going to go. The loopback is directly attached to router 4. So router 4 is not the issue here. The issue will be on router 1. So let's get into do show IP route OSPF. And the 10.1.4, where is it at? So router 1 right here. It is an intra-area OSPF route, 10.1.4.0. You can see there is the metric of 75 via 172.16.0.1 out its Ethernet 0.0 interface. And as you can see here, for everything, router 1 is going to go out its Ethernet 0 interface. So if we pull back the diagram here, you'll see that there's the Ethernet 0 interface. And the reason for this is that when router 1 is receiving this route right here, this is showing up as an intra-area OSPF route. So it wants to go this way, right? And that's what we're seeing in the routing table because it is an OSPF learned route. So what we're going to do is we are going to manipulate the administrative distance of EIGRP. And let me see here. Okay, I see what they're going to have. Okay, I see what they're doing. So they're going to have us manipulate the administrative distance of EIGRP, and we're going to drop it to 90 and 100, which is below, right? Because everything over here has an administrative distance of 110, right? Over here, we're going to drop it. Well, I shouldn't say drop it from 90 because it's 90 by default for internal, but the externals by default are 170. And we are redistributing into OSPF. So all the EIGRP routes that are over here would be OE2s, but all of this OSPF information here that we're redistributing into EIGRP has an administrative distance of 170, right? So what we're going to do is we're going to lower that administrative distance for external DEX EIGRP learned information down to 100. And so let's do that on only router 1. So here on router 1, if I was to simply go into, as soon as we get the control back of the screen here, there we go. So router EIGRP 100, the distance command, right, for EIGRP, and we set the internal routes, we'll leave those at 90, and then the external routes, we're going to make 100. And again, we're only doing this on router 1. So what we should see on router 1 is now all of the 10 networks should be going, do show IP route, oops, sorry, do show IP route EIGRP. So the adjacency went down and came back up, and now for all of these routes, we're now going toward router 2. So for all of these external EIGRP learned routes, and these are all of the routes that were redistributed into EIGRP from OSPF, and you can see up here on router 1, they all showed that OSPF was going to be selected for those routes. Because again, when we have two routes that have equal subnet mask lengths, the number one tiebreaker after longest match, which is the longest match in terms of the subnet length, the number one tiebreaker after that is administrative distance. And so on router 1, it's getting the routing information from both the EIGRP and OSPF, but the OSPF routes get installed because of the AD of 110. We then turn around and lower the administrative distance here of EIGRP external routes to 100, making the redistributed information that's coming in via router 4 into the EIGRP domain more preferable than the OSPF routing information that router 1 was naturally learning. Again, because it had intra-area routing information with an administrative distance of 110. There we go. With an administrative distance of 110, we tweak EIGRP so that it's more attractive, more reliable, and now router 1 will send all of that traffic towards router 2. And we did all of this in large part initially by using the route maps and the ACLs. And these will become very, very critical as we ease into BGP. You're going to find out that the prefix list and the route map are critical in order to manipulate the path attributes of the BGP in LRI. All right, well, this wraps up the third and final discovery activity for Chapter 4, where we've been working and looking at redistribution, prefix lists, ACLs, and route maps. All right, thanks for watching, guys, and I will see you tonight.